Hey everyone, welcome back to our channel. Today, we're diving into a topic that has sparked controversy, curiosity, and even fear worldwide. Something terrifying is said to be happening at CERN, the European Organization for Nuclear Research, that could put us all at risk. But what exactly is going on there, and why are people like David Icke raising the alarm? In this video, we'll break down the mystery, the science, and the speculation surrounding CERN's Large Hadron Collider. So sit back, subscribe, and let's get into it. The idea of conspiracies coming to life has intrigued people for years, and some of the most groundbreaking discoveries in modern history have been made possible by CERN, the world's leading scientific research facility. But what if I told you there's something far more concerning happening behind closed doors? Today, we'll dive into some startling claims made by David Icke, who believes that CERN's experiments pose a threat not just to science, but to all of humanity. Prepare yourself, because what you're about to learn could change the way you see the world forever. CERN's mission is to uncover the mysteries of the universe. Its research has led to incredible breakthroughs, from the discovery of the Higgs boson to exploring the very fabric of space and time. But with great power comes great responsibility, or in this case, significant risk. Since its founding in the 1950s, the European Organization for Nuclear Research, more commonly known as CERN, has been at the forefront of daring scientific experiments. While its revolutionary work has earned widespread acclaim, it has also raised serious concerns over the years. Some of these experiments have sparked fears about the potential dangers, including the possibility of creating black holes or other unknown risks. The disruption of reality, or so some fear, began on September 10, 2008, when the Large Hadron Collider, LHC, went live. This monumental project quickly became one of CERN's most famous and controversial endeavors. Stretching over 27 kilometers, the LHC is the world's largest particle accelerator, equipped with powerful superconducting magnets. As particles race through its tunnels, they're propelled to incredibly high energies by a series of accelerating devices. Despite its hefty price tag of over $4.5 billion, many argue that the investment has been worth it. Thanks to the LHC, scientists have identified the Higgs boson and other previously unknown particles, leading to some of the most groundbreaking discoveries of our time. Imagine this colossal machine sending particles hurtling around its massive loop at speeds close to the speed of light, completing over 11,000 laps every second. It's a marvel of engineering and human ingenuity, opening the door to knowledge once thought unreachable. To achieve this, the LHC uses powerful electromagnets to create a magnetic field nearly 1,000 times stronger than Earth's. But as particles approach their top speed, nearly the speed of light, there are concerns about the potential consequences. Could this unprecedented experiment be flirting with forces we don't fully understand? The powerful magnetic fields generated by the LHC don't just stay within its tunnels. They can affect surrounding devices and potentially even interact with Earth's magnetic field. Inside this colossal machine, particles are accelerated to near light speeds and then smashed together head-on, creating bursts of energy and new particles. Most of these particles vanish in an instant, lasting only a few fleeting moments. To capture every detail of these brief, high-energy collisions, scientists use specialized detectors strategically placed around the impact zones. Analyzing the immense amount of data produced by these collisions is no small feat. Each year, the LHC generates more than 15 petabytes of data, enough to fill a staggering amount of hard drives. In 2017, a significant milestone was reached when the LHC managed to store over 20 petabytes of data, equivalent to more than 250,000 movies. But what exactly are scientists hoping to discover among all this data? One of the most intriguing observations involves a peculiar type of quark. These tiny particles, known as quarks, are the building blocks of everything around us. They come in different varieties, almost like flavors of ice cream, with some being highly unstable and quickly transforming into other particles. Researchers have a special interest in the beauty quark, a fascinating type with an exceptionally short half-life. What makes it so special, and why are scientists so eager to study it? Beauty quarks are incredibly fleeting, existing for just a fraction of a second before decaying. Typically, they break down into lighter particles known as leptons, which can either be electrons or muons. Scientists expected these decays to split evenly between the two, but the data from the Large Hadron Collider revealed a surprising twist. About 70% of the beauty quarks were transforming into muons, rather than dividing equally between electrons and muons as anticipated. This unexpected result hints at a hidden player in the mix, a mysterious particle that hasn't yet been detected. It's like finding a missing piece in a puzzle you thought was complete. This discovery has left scientists wondering, could this be evidence of a completely new set of rules governing how particles interact? If so, it could challenge the long-accepted standard model of physics and suggest there's much more to uncover about how the universe works. The idea of discovering new physics is thrilling, hinting at answers to some of the biggest questions about the cosmos. The Standard Model, which has long served as the rulebook for understanding the behavior of subatomic particles, may not tell the whole story. This anomaly could open the door to a new chapter of discoveries, pushing the boundaries of what we know about the universe. Think of the Standard Model of particle physics as a blueprint for everything around us. It covers almost everything we know about the tiniest building blocks of nature. Despite its incredible precision, however, scientists still consider it incomplete. The model explains three fundamental forces: the strong force, the weak force, and electromagnetism. Yet, it makes no mention of dark matter or gravity, the mysterious forces that make up most of the universe. Recently, something unusual caught the attention of scientists. During their experiments, the data they gathered didn't match the predictions of the Standard Model. Strange results aren't entirely unexpected, especially given the vast amounts of data pouring in from experiments like those at the LHC. But this time, there was something different. Intrigued, researchers decided to dig deeper, curious about what might be causing these unexpected outcomes. Their theory? There could be something entirely new at play, a phenomenon they've dubbed Z prime. This could represent a whole new class of particles, potentially carrying a previously undetected force. Since this force hasn't shown up in any experiments until now, it may be incredibly weak, yet still powerful enough to explain these surprising results. If confirmed, Z prime could point to a hidden layer of reality, suggesting there's far more to the universe than we currently understand. While researchers are still figuring out how this new force might interact with unconventional particles, they suspect it behaves differently when it comes to electrons and muons. If they can confirm the existence of particles carrying this mysterious force, it would be a groundbreaking moment in the world of physics. Such a discovery could help solve major cosmic puzzles, offering explanations for long-standing mysteries around dark matter and the role of the Higgs boson. Some scientists even believe that this new force could play a key part in unifying all the fundamental forces in physics, a quest that has intrigued researchers for decades. Elon Musk has pointed out that between 1998 and 2008, CERN constructed the largest and most powerful particle collider in history, known as the Large Hadron Collider, LHC. This massive project brought together over 10,000 scientists, along with numerous organizations and laboratories from more than 100 countries. Situated about 175 meters below the surface, the LHC is housed in a 27-kilometer-long tunnel running beneath the French-Swiss border near Geneva. With beams carrying an energy of 3.5 tera-electron volts, the LHC's first collision was a milestone event, producing energies 4 times greater than any previous experiment. Now, with this new potential force on the horizon, the LHC could once again be on the verge of rewriting the rules of the universe, opening up a new chapter in our understanding of reality. After undergoing significant upgrades, the energy output of the Large Hadron Collider, LHC soared to an incredible 6.5 tera-electron volts per beam, surpassing previous records by a wide margin. Elon Musk has described this colossal machine as a marvel of engineering, designed to precisely smash proton beams together at mind-bending speeds. But that's not all. The LHC can also fire lead ion beams, an extraordinary feat that takes place once a year during a dedicated month of experiments. During these special sessions, scientists meticulously study the collisions to confirm or challenge various particle physics theories. The LHC's primary mission revolves around unraveling some of the biggest mysteries in physics, such as the discovery of new particles predicted by subatomic theories and uncovering the true nature of the Higgs boson. At this scale, hadrons, the fundamental units of matter, take center stage. These particles are intricate structures made up of quarks, held together by the strong force, much like glue binds atoms and molecules. Protons and neutrons are the most familiar hadrons, but there are also lesser-known particles like pions and kaons, whose existence was first discovered in the mid-20th century through cosmic ray experiments. By bringing two opposing streams of particles together, the LHC orchestrates what can only be described as a massive cosmic collision. These high-energy impacts are like miniature recreations of the universe's earliest moments, giving scientists a rare glimpse into the fundamental forces that shape everything around us. The discovery of the elusive Higgs boson has been a game-changer in the world of physics, making it easier to explore one of the most mysterious aspects of our universe. Imagine it like ripples on the surface of a pond. The Higgs boson is an elementary particle that appears as a wave within the Higgs field, a kind of ripple in the vast quantum sea. Unlike particles that make up ordinary matter, or those that carry fundamental forces like electromagnetism and the weak nuclear force, the Higgs boson stands out as a unique addition to our ever-growing collection of particles. This groundbreaking discovery was made at the Large Hadron Collider, LHC, the world's most powerful particle accelerator. It happened thanks to the combined efforts of two major research teams, a TLAS and CMS, working side by side. The monumental announcement was made on July 4, 2012, at CERN, a moment that marked a turning point in our understanding of the universe. The most compelling evidence for the Higgs boson's existence came from two unusual decay pathways. In one, the particle quickly transformed into a pair of Z bosons, which are responsible for mediating one of the fundamental forces of nature. In the other, it broke down into a pair of photons, a process governed solely by the rules of quantum mechanics. These observations confirmed the Higgs boson's presence, solidifying its role as a key piece in the puzzle of how the universe operates. The discovery of the Higgs boson wasn't the end of the story. In fact, it was just the beginning. Rather than closing the chapter on this mysterious particle, it ignited a wave of new research. Confirming how the Higgs boson decays has been one of the most significant scientific achievements since 2012, and CERN predicts that the hunt for this elusive particle will only intensify, especially as the Large Hadron Collider, LHC, enters its next phase. The upcoming high-luminosity upgrade, scheduled for completion in 2029, will be a game-changer. This enhancement will allow the LHC to perform more collisions than ever before, providing researchers with more opportunities to observe events that might challenge or extend the standard model of particle physics. Once the upgrade is complete, scientists expect the accelerator to produce an astonishing 15 million Higgs bosons each year, up from just 3 million in 2017. This dramatic increase could be key in uncovering new insights about the Higgs boson and its various forms. Why is this spike in production so important? Some theories beyond the standard model propose that there could be up to 5 different variants of the Higgs boson. While some may be harder to detect than the basic form, increased production will give scientists a better chance of identifying these variants and understanding their properties. If proven, this could open the door to a deeper understanding of the universe, potentially revealing new physics that reshapes our understanding of reality itself. The Higgs boson and the Higgs field play a crucial role in the universe, especially in its early days. The Higgs field creates the vacuum in which everything exists, shaping the very nature of space itself. Without it, the cosmos would lack mass, and the tiny building blocks of matter wouldn't exist. Imagine a universe without matter. There would be no atoms, no stars, and ultimately no life. The fundamental components that hold everything together would simply be absent. Because the Higgs boson was so elusive, it earned the nickname God particle. This label came about after a physicist named Leon Lederman jokingly referred to it as the goddamn particle in his book. The publishers, perhaps wanting to keep things a bit more family-friendly, changed it to the God particle, and the name stuck, even as it sparked debates between the realms of science and religion. Despite any controversies, the Higgs boson and its field are essential for giving mass to everything in the universe. Without them, there would be no stars, no planets, and no humans. Researchers are diving deep into the properties of the Higgs boson for two main reasons. First, they are eager to uncover more about the early stages of the universe, hoping to understand how it all began and evolved into the vast cosmos we see today. Researchers are diving deep into the mysteries of the cosmos, particularly the origins of the physical vacuum that surrounds our world. One of their main areas of focus is understanding how this vacuum remains stable over time. An intriguing aspect of the Higgs field is its inherent potential energy, which is always present and influences the physical vacuum. This unique characteristic is vital for the formation of the universe as we know it. Scientists believe that by grasping and harnessing this potential energy, they can shed light on fundamental forces, such as the weak force operating over minuscule distances and electromagnetism, which acts across vast expanses. To unravel these complexities, researchers need to study the interactions between Higgs bosons, which requires creating pairs of these elusive particles. While the Higgs boson has helped clarify how other particles acquire mass, its own mass remains a mystery. Theoretical symmetry doesn't provide a reliable estimate for it, leading to instabilities that could disrupt the physical vacuum through quantum fluctuations. Fortunately, these disturbances unfold over a longer time frame than the age of the universe itself, offering scientists a unique window to explore these fundamental questions about our reality. The search for the Higgs boson's mass continues, and scientists are on the hunt for new particles that resemble Higgs particles. This quest drives the need for more in-depth data analysis and, if possible, access to higher energy colliders. A decade after its discovery, hundreds of dedicated specialists around the globe are still working tirelessly to solve these intriguing puzzles. The journey to understanding the Higgs boson has been a long one. First proposed in 1964 and only confirmed in 2012, this enigmatic particle has posed challenges due to its large mass and incredibly short lifespan. To create such a massive particle, scientists needed high-energy colliders capable of compressing vast amounts of energy into a tiny space. Once generated, Higgs particles decay rapidly into a flurry of other particles, making them difficult to track. Only a small fraction of these decay products can be distinguished from the overwhelming background noise. To tackle this challenge, scientists construct enormous and sophisticated detectors designed to identify these elusive particles. They sift through billions upon billions of proton collisions, hoping to uncover the secrets of the universe hidden within these fleeting moments. To understand the concerns, we first need to know what CERN is. Located near Geneva, on the border between France and Switzerland, CERN is one of the world's largest and most respected centers for scientific research. Their main tool is the Large Hadron Collider, LHC, a massive machine designed to smash particles together at nearly the speed of light. This helps scientists study fundamental particles and forces, hoping to unlock the secrets of the universe. It was at CERN that the Higgs boson, or God particle, was discovered, which implications. He has suggested that scientists are tampering with dimensions and may accidentally open portals to unknown realms. This theory is fueled by the fact that the LHC's experiments involve recreating conditions similar to those right after the Big Bang, which some fear could lead to the creation of black holes or gateways to other dimensions. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.